Hello everyone, my name is Daphne Weiss. I am a PhD student at the BCBL in the Spoken Language Group, and this presentation is going to be a brief introduction to building pupillometry experiments in Experiment Builder. For those who aren't familiar, Experiment Builder is a proprietary software that comes with the EyeLink systems by SR Research. It is a paid software that requires a license key, but there are some situations in which it can be useful. So I'm going to start by giving you a sense of kind of when you might want to consider using it as opposed to other experiment building softwares. Then I will show you briefly what the program looks like. And then I'm going to dive deeper into how to actually modify either the example experiment that I've built or any example you might find online, which is a really approachable way to get started with this software rather than building your own experiment from scratch. I will note from the outset that I intend these slides to be a bit of a reference, so there are some things I'm not going to cover in depth or at all, but hopefully if you do choose to edit the sample materials I've provided or any template, these slides can be useful to you as you're going through the process. So with that said, I'll start by going over some of the reasons you might consider using SR Research's software over something like PsychoPy. The biggest reason would just be if you want to stay in the SR Research ecosystem. So what do I mean by that? Well, the big benefit of using Experiment Builder is that it's plug and play with the equipment that we already have at the BCBL and that a lot of institutions already have. So this software is designed to work seamlessly with the eye tracker. None of the features are in beta that I know of. And there isn't a long involved process of getting the software to speak to the hardware. Everything just usually works. So if you are doing a simple experiment and you just want to get started, this can be an easy way to dip your toes into the water. And I emphasize that second point about it being a simple experiment because there are a lot of resources for Experiment Builder, especially if you're using a really common paradigm. So for example, if you wanted to do an eye tracking visual world paradigm, you could just download a pre-existing template, plug in your stimuli, and be ready to go with minimal overhead. So that I would say is the biggest use case for Experiment Builder is if you have access to the software and want to do something relatively simple, it can be one of the faster ways to get started. Um, the other thing would be if you are someone who prefers either to avoid writing code or just in general is a visual thinker. If you like laying out experiments like flowcharts. You'll see what the interface looks like in a moment and you'll maybe understand what I mean by that better. But I could imagine this sort of interface appealing to some people over the timeline type situation of PsychoPy. I will make a note here that you can write custom code in Experiment Builder. It is possible, but if you want to do it, you're going to have to write an entire custom class in Python and then slot it into the visual flow of a standard experiment. So you can do that. If you don't know what that meant, or if it sounds like a lot of work, you might be more inclined to using something like PsychoPy, where you can put in even just like a line of code with relative ease while sticking with the GUI for everything else. So that's just a quick note. But with that, I'm going to give you the logistical information about how to actually boot up Experiment Builder. So as I said, it is a proprietary software, which means you cannot run it without a license. At the BCBL, we use the physical licenses, which are these little USB keys that you'll have to plug into your workstation. It can be a laptop or it can be your like hot desking PC or whatever. Um, but the important thing is that you have it plugged in all the time. If you're watching this from another institute, you might have access to a network license key, but I'm not going to talk about that. And if you are watching from the BCBL, to get this key, you're going to have to go through the ticket system, which probably won't surprise anyone. So it is a loan ticket, and you'll just request the license and keep it for as long as you are working on the experiment. The really, really important caveat with this is even if you have the USB plugged in, it's possible it doesn't register. Usually not, but it can happen. And if that happens, you're going to get this pop-up that says that it will run in demo mode. And if this happens, stop, do not pass go. Do not ever run Experiment Builder in demo mode. Demo mode is meant for people who are considering buying the software, and anything that you build in demo mode cannot be opened in a licensed version of Experiment Builder, which is what you will need to open it in to deploy your experiment. So if you ever see this pop up and you're not sure why, talk to IT, figure something out, but don't continue because you won't be able to use whatever you do. Okay, with that said, I wanted to show you what an experiment looks like running, but probably because of permissions, I'm unable to record my screen while the experiment is running. So I'm going to tell you what the experiment does, and then I'm going to show you how that logic translates into Experiment Builder's design window. And then after that, I'll break down in more detail the components that you would use to either build your own experiment or edit the experiment I'm presenting here. So this is a very simple pupillometry appropriate example. Basically, what you'll see if you open this experiment is a fixation cross. I believe I have it set for 8 seconds for a baseline pupil response. And then there will be a stimulus. I think I have single words in here. And then there is a prompt to tell the participants to type the word they just heard and press enter to finish. So it's a very, very basic just speech perception example, similar, I believe, to the example you would see in PsychoPy if you did this whole workshop. But let me show you what that simple example actually looks like in Experiment Builder. So here we go. What I'm showing you here is the routine for just the part I showed you the screenshots of, just the fixation cross and typing block. So when you open Experiment Builder, you see this big workspace. Every section of your experiment starts with a start node. And then you define visual elements using a display screen. So you can see, obviously, this one is the fixation cross. I've built just a cross in the center of the screen. And if I go back, I update a variable. I set a timer to tell Experiment Builder that fixation cross should last 8 seconds, which is over here, you can see. Then I play my stimulus, and I will explain to you how you actually access individual stimuli files later. I have another timer to make sure that that stimulus plays the whole way. And then it flows to this big, scary conditional loop. I did not make this. This is something I grabbed from SR Research. And this is something to keep in mind that some elements of an experiment that you might expect to be implemented may or may not have been implemented cleanly in Experiment Builder. So if you want to do something that requires a lot of flexibility, this is one example of where I might personally lean towards PsychoPy, but it's usually possible to troubleshoot with the forums if you want to do something that's a little out of the box. But anyway, this is the text entry box, all of this. And then down here is where we actually send what the participants wrote to our data files. So that's all I'm going to show you for now. You'll see screenshots of other elements of this experiment when I go through the components in PowerPoint. So let's talk about how to actually navigate Experiment Builder if you wanted to edit that example or make your own. As I said, the big white grid area is called the workspace. You'll sometimes see it called the graph when it's in this mode where you're building the flow of your experiment. This is the component toolbar at the top. The way you build an experiment in Experiment Builder is by dragging these components onto the graph and then drawing arrows between them. You can switch what component type you are dragging in the corner, and I will explain those in a bit. And then, as I said, you will build display screens in the exact same way. There's a toolbar at the top, you drag them onto a workspace, and it's completely visual. One thing to keep in mind, if you want to move and change what's actually visible in the workspace, you have to do so up here in the overview pane. Intuitively, you might think you can click on the white space of the workspace and drag, but it doesn't let you do that. You have to use the overview pane, so you can click and drag over there. Beneath that is a structure pane, which shows absolutely every single element of your experiment, including down to like individual lines of text on individual display screens. So if you can't find something that can be somewhere to look, it also helps you if you need to modify things about the hardware that's connected. The most important thing here is the properties pane. This is where you take a generic component and make it do what you need it to do for your experiment. So we're going to go into this in a little bit more detail, but this is where you'll customize experiment components and hardware settings. And then finally, this is the notes block. It seems self-explanatory, but what I want to highlight it for is to let you know that if you download a template from SR Research or if you download my sample experiment, most of the time there is going to be like documentation in that box that helps you understand what's going on in the experiment. So the example I made is modified from an SR Research template, and I left in all of their notes. So this tells you this is a block sequence, and it's going to run based on this property in the properties pane. Um, so this can be very helpful if you are working from an SR research template. Obviously, you can also put your own notes here, and it is helpful to do so if you're going to forget, which you probably are, what you did. Now, let's go a little more in depth to the anatomy of an experiment builder experiment. So, as I said, components, you drag them onto the graph to make your experiment flow, and these come in three types. Actions are most of the things that you do in an experiment. So if you're displaying a stimulus, updating a variable, sending a result to your results file, almost anything you do like in the experiment flow itself is going to be an action. So I've highlighted all the actions in this sequence. But anything outside the basic flow of component arrow is going to be defined using a trigger. So a lot of times you need to wait for time to have passed before something happens. You need to wait for a participant to do something or look somewhere. Or you want to do different things depending on the value of a variable, right? So all of those different examples of situations are times when you would need to use a trigger to change the flow of the experiment. So I've highlighted those here. They're usually circles, but if you need a conditional, like an if else, then that's going to be a triangle. Pay very close attention to which of the ones is, or to which side of the triangle is no versus yes. Um, because if you connect, anyway, you connect what happens on a false to the X and what happens on a true to the check. But anyway, the third type of component is the other component. I'm not entirely sure why they called it this in the menu because basically it's variables and results. If you want to change a variable, you need to first define it by dragging it onto the canvas. These other things do not actually go into the flow of your experiment. You leave them floating somewhere, and then you use an action to modify them as you go. So the two big use cases of this are variables and data files. There's also an accumulator that I'm not going to talk about because I haven't personally used it much. Now, one of the really important things to understand about Experiment Builder is the logic of how it executes your experiments and how SR Research wants you to build your experiments. So Experiment Builder works in layers, and these layers are made up of sequences. You can think of these as loops. They're groups of actions that you can repeat as many times as you want, or you can only run through them once if you so choose. The simplest possible experiment where you're showing one type of trial and recording using the eye tracker once is typically going to have three sequences. So you'll need a block sequence, a trial sequence, and a recording sequence. This schematic that I'm showing you is what SR Research includes in the manual, what they suggest should go in each of these levels of your experiment. So it's 4 layers and 3 sequences. And I'm going to break this down panel by panel to give you an idea of how you would actually do this in practice. Something to realize is that these different categories, you can have more than one. It's not like you only have one block sequence, and it's also not called a block sequence until you call it that, right? So this is just a flexible framework for you to think about what needs to go in your experiment. It's not like you're going to drag a different component for a block sequence versus a trial sequence, if that makes sense. So at the very top level, when I first launched Experiment Builder, what you would see is something like this. There's a start node, there's whatever happens before your experimental trials, and then there is your block loop or loops, as many as you need. But in this basic example, we only have one block sequence. And then you exit that sequence and you do a goodbye or a debriefing. So the idea behind this top level is that once you've gone through everything visible, the experiment is over, right? But if we descend a little bit, now we can see what's happening in individual blocks. Now they suggest that you can put calibration here. If you have multiple blocks in a pupillometry experiment, you probably don't need to be calibrating every time. Even with eye tracking, I'm not sure that you want to calibrate at every block. So I believe in the example experiment, I moved the calibration outside to the very top layer. But what might be more useful to put there would be the like a break or something that happens every block, but not every trial. And then, of course, you do have the trial sequence. Something to note about the blocks is that you will need to set how many times it repeats in the properties pane. Over here, you'll just say iteration count, and that'll tell it how many times you run through this same block. Then, of course, we can descend into the trial sequence, which SR Research says should include these four components. So trial preparation is a prepare sequence that you can just drag in. A drift correct, you can also drag in. And then you'll have to put your recording loop. And then you'll come out of the recording loop to send feedback or to display feedback, rather. So one thing to realize is you might intuitively think that this is the deepest layer of the experiment, right? This runs once per trial, but it's not. And the reason for that is that we also have a recording sequence. You don't want to be collecting eye tracking data the entire time participants are doing your experiment because you don't care about the gaze data or the pupil data while they're reading your instructions, I would imagine. In most experiments, there is a short period of time in which you actually care what the pupil is doing. And that short period of time is all that needs to go in the recording sequence. So you will display the stimulus and wait for the response, typically. Um, it's possible in a pupillometry experiment, you don't even necessarily care what's happening during this response loop that I showed you earlier. So you might literally just have like a 3 or 4 component recording sequence. The important thing is that you put anytime you need to have the eye tracking data, that you put that within a recording sequence and you will check record in the properties pane. That's what makes this a recording sequence, is that you've told it record this sequence. Like I said, all of these categories of sequence are just a way for you to structure the experiment. It's not literal different types of sequences in the software at like a software level. Okay. Just very briefly, there are a few ways to navigate between these different layers. If you want to go like down a layer, you need to double click on the shaded area on the graph. By contrast, if you want to go up a layer, you'll usually use the navigator breadcrumbs at the bottom. Other ways to do it, I don't know if I'm going to show these, no. So other ways to do it are to switch tabs at the top, depending on what you have open, or to use the structure pane. So let's talk about how to actually edit an experiment. So let's say you want to build a pupillometry experiment, but yours, understandably, is going to be a little different than the example I showed you. What do you need to know? The first and most important thing is the data source. So every experiment builder has some version of this. It's where you define the trial parameters that you're actually going to be showing, what conditions participants are exposed to. Any data you need to show the right stimuli and analyze your data must be in a data source. So this is something, if you edited my sample experiment, you have to change because you probably don't want to use 8 random Spanish words, all in one condition, right? So what you can do is either build your own CSV in like Excel or something and import it, or you can build it in Experiment Builder itself. I don't really recommend that, but it is possible. And the other thing is, if you're using counterbalancing or random lists for each participant, that is absolutely possible, but you still need one like master data source where you tell Experiment Builder every single stimulus it might encounter on a per participant level. I won't talk too much more about that, but do know that is an option if you go into the documentation. And then when you are editing the experiment itself, you just change these 3 parameters on your loop, the trial loop usually. You'll tell it how many trials are going to happen, how many to split it by. So if you have 3 blocks and 12 total trials, then you would put 4. Oops. And then, of course, you actually need to link to the data source here. So you'll click there's a little 3 dots over here. You'll click there, find the data source, and it'll tell you, okay, I found a data source with 3 columns and 12 rows. This brings us to the library manager, which is where you import all those stimuli that you might reference in your data source. You can drag and drop things into the directory itself, but the easiest way to make sure absolutely everything maps the way it's supposed to is to go to the library manager by pressing Control L, and then importing what you want, and it will arrange it for you into this nice set of subdirectories for audio, images, whatever. As I said before, the properties pane is where you turn a generic component into a component that makes sense for your experiment. So if you were going to edit any sample experiment, you would need to edit the properties to make sure that everything that you want to happen in the experiment happens properly. So for example, if I have an 8-second baselining block and you wanted it to be 10 or 4, you would need to find the timer component and change it. Now, these properties can be static, like what I just said with timing, or something like volume. If you just want everything to play at the hardware default, then you would set volume to 1. But it can be a dynamic reference. This is a little bit more complicated, but I'm going to do my best. So if you want to use a variable or a reference to another component, you'll enclose the address of that other component in @signs. And the good thing is you don't actually need to figure out these addresses yourself. You'll use something called the attribute manager to find the address of the other components. Usually, the reason you would do this is to get to a value that's in your data source. So whereas in something like CyclePy, you can directly reference it because it's imported as a variable, in this case, you're going to need to tell Experiment Builder where to find this variable. So you'll go into the node selection pane, find the relevant data source, because you could potentially have more than one, and then pick the column, which is calling an attribute, that contains your stimulus. So once you've done all that, it's going to give you up here an address that you can usually just click OK to fill it in, or you could copy and paste it if you were doing a formula or something. And that's how you find either usually the current value of a variable, in which case you would need to find the variable, not the data source, or a value from your data source, like the stimulus column, which is the example I've shown here. This is where it says get something from the sound file column to play. The other thing that is super duper important that you have to do when you're editing an experiment is check the messages. So depending on your level of background when you're watching this, you may or may not know that the data file when you run an experiment is a kind of text file where all of the information is displayed line by line. So that includes the gaze data, the pupil data, timing information, but also these things called messages, which send information about what happened at each time point in your experiment. Some of these are going to get sent by default just by adding a component. So if you've added a text entry, or not a text entry, sorry, a key press component, every time the participant presses an allowed key, it's going to send a message that says the participant pressed this key at this time. But a lot of times you're going to want to send your own messages, whether to find out when something happened or to find out what a participant did that's not sent as a message by default, or critically to send information about what condition was presented, because that is typically not going to be sent by default, but you're going to want to get from your data source this was in whatever training condition or whatever stimulus condition, because anything you want to use to analyze your data to keep it all in one file is going to have to be a message on a line in your experiment or in your data file. So the two ways you can do this are to set messages in the properties pane on the component itself. So for example, this one, you could change what the message says when it runs the drift correct, or you could take it out if you don't care. This can be helpful for data on or for timing information. You can also send custom messages whenever you want. So to do that, you'll drag a send message component into your workflow, and then you'll just tell it what you want the message to say. So in this case, I have put in a formula by doing an equals, and I've made it response plus, you'll see the @signs, meaning this is a dynamic reference, the variable of what was put into the text response box. So it's very important when you're editing an experiment to make sure you send a message for everything you care about if it's not being sent by default. Another key hardware note here is that you should always separate chains of messages with a timer. The eye tracker itself can only handle 2 messages per 1 millisecond. So if you're sending like 5 different variables each trial, which is reasonable, you want to make sure that they're chunked no more than 2 at a time with a 1 millisecond timer between them. Otherwise, you might lose data. The results file is a separate CSV file that you can generate if you want to. It actually might be a TXT, but it's a text file that you can generate if you want to, as many as you want, but it's not done by default. I like to do this as a fail-safe so I can see every value from my data source if I forgot a message, for example, or if I want to cross-check my messages. But to do that, you need to initialize the file by putting it on the graph and then add it to your experiment flow. And then at the end, your data comes out in one directory per participant. You can see you get an EDF file, which is the text file I was talking about before, but you also get a results file, training, that's the name of the sequence, whatever you call this file. You also get a text document that includes all the variables you want. So I find this very helpful. Finally, I'm going to talk to you about how to actually edit a sample experiment if you choose to do so. And just for the sake of time, I'm going to use screenshots rather than going into Experiment Builder and doing it. But if you are going to edit the experiment I showed you, these are the steps that I would recommend taking. So first is to do the big picture revisions of the flow of the experiment. So adding and removing components, editing static properties, making sure that the overall sequence of events is what you want it to be for your experiment. So for example, in here, you might want to add practice trials, and that's pretty simple to do. You would just need to add a new sequence, and then within that sequence, add a trial sequence. With probably just a copy paste of the task, right? So that's pretty simple to do, but you want to do it early just to make sure that you've mapped out everything that should happen in the experiment. Next, you'll need to import the stimuli you plan to use. This is important so you make sure that everything you reference in the data source actually exists. Then you will revise or replace completely the data source. I would recommend replacing it completely, especially since in a real experiment you're going to have extra conditions that I didn't consider here. Then I would revise the display screens. So you could change what instructions I'm showing, you could add images. If you're doing something more advanced with gaze positions, you can add interest areas. But all the stuff that's actually being shown to participants, this is a good time to do it once you've actually imported the stimuli because now you'll have access to them and you won't get any weird errors, hopefully. And then at the end, I would review the dynamic things like the attribute references, the variable references, those things I told you were a little bit harder to nail down. But these will change for your experiment. So you want to go through and make sure that it's referencing the correct column in your data source when it's playing sound files, for example. Or if you added a new variable, you're going to want to integrate that into the flow wherever it's relevant. And then finally, I said this before, but you'll really want to make sure that you have every message you might want and that your formulas are correct. Actually, in this screenshot, it's not. It should have an equal sign to show it's a formula. The earlier screenshot was correct. But yeah, you're going to want to make sure that you both are sending all the messages you want to send and that they say what you want them to say. Because it's really easy to forget something or duplicate the code. Basically, this little part at the front here, you're going to end up searching for to find the message later. So if you have two that are just response, that's going to be really annoying. So make sure these are distinct. As I said, or maybe I didn't say, my sample does not have enough messages for the typical experiment. You're going to need to add some. So that's why I put this, I put a pretty big emphasis on this. Finally, just a few logistical notes about how to actually deploy an experiment, and I'll go quickly here because this is probably something you can read about. So an experiment builder experiment has to be deployed before it can be run. Basically, this is compiling it to an executable. Um, technically, if you were at the BCBL, you're going to need to talk to the lab or whoever's in charge of the eye tracker because running an experiment builder experiment with proper timing requires admin rights, which we do not have on the lab computers. So I can't tell you all about the script now, but there is a separate script. But in principle, the last step is to create this executable file. Doing this clears out anything in your directory that is not used in the data source. It clears out extra stuff you put in library. It clears out fake data from like sample runs. So only deploy when you're ready. Um, Also, because every time you make changes after that, you'll have to redeploy. So this is the last thing you do really before you pilot, and then you might edit one more time and deploy one more time, typically. You can test an experiment outside the lab. I put a slide here with the main settings you have to change. I'm not going to go into them now. Um, and finally, I wanted to point you to some extra resources you can use. So the biggest one is the SR Research website itself. It is a locked forum, so you'll need to make an account, and you may need to email them to make sure they activate your account from experience. But this is where you'll find templates, manuals, tutorials, other webinars, and also obviously the support forum. They are paid to help you, so it can be a decent place to get help with your experiments if you need it. If you're watching from the BCBL, you also have access to a webinar that SR Research did when they installed our eye trackers. So this is very extensive. It goes into everything I covered and probably a bit more about Experiment Builder, but also the hardware. Things like, I believe it tells you how to calibrate participants, like anything you need to know about the EyeLink system itself is there. And then finally, there is a manual in the app that you can use. It's a little cumbersome at times, but it's very extensive. So I do recommend using this resource. There are physical copies in our labs, at least in Corta. So this is another place you can go. So thank you very much for your attention. And if you have any questions, please feel free to email me. It's on the slide. Thank you.